In these examples, we'll look at flow rates in IV pumps. Example number 1. The nurse hangs a new 1,000 milliliter bag of natural saline at 0500. If the pump is set to run at 100 milliliters per hour, at what time would the nurse expect the bag to run out? So we're interested in this case looking at the time. At what time should we expect the bag to be finished? In this case, we'll look at it in hours. So we have a 1,000 milliliter bag, and it's being infused, we know, at a rate of 100 milliliters per hour. So if we want hours to be our ending unit, we'll have 1 hour in the numerator, 100 milliliters in the denominator. So it's a basic division problem here. For every 1 hour that passes, we'll have 100 less milliliters in our bag. So over the course of 10 hours, we should expect the bag to be empty. But that's not all that we're interested in. We want to know exactly what time the bag will run out. So if we started at 0500 and this occurs over a 10-hour period, we should finish or expect the bag to be finished at 1500 hours. Stated another way, in more standard time, this is 3 p.m. Example number 2. An IV of D5W 1000 milliliters was ordered to infuse over 8 hours at a drop rate of 42 per minute. The drop factor is 20 drops per milliliter. After 4 hours, you notice that only 400 milliliter has infused. So we're asked to recalculate the rate in drops per minute such that we finish on time. So there's a couple of steps in this case. First, we need to recognize that we started with 1,000 milliliters, and we notice that we've only infused 400. So how much is left to infuse? So by subtraction here, we find that there's 600 milliliters left to infuse. And we want to finish on time, so we need to understand how much time is left. Originally, we were expecting that it would take 8 hours, and after 4, we noticed that the 600 milliliters is still remaining. So we have another 4 hours left for the infusion. So finally, we want to, again, make our calculation for what is the number of drops per minute that we should set the machine to in order to finish on time. So given our calculations here, we have 600 milliliters remaining that needs to be distributed across 4 hours. The drop factor given is 20 drops per 1 milliliter. This will give us our solution in drops per hour. So the last thing we need to do is a conversion from hours to minutes. So we have 1 hour is equivalent to 60 minutes. With our cancellations here, we get that the hours will be removed, milliliters will be removed, and our computation here should give us 50 drops per minute for the solution. So we'll reset the machine, and over the next 4 hours, it will infuse the remaining 600 milliliters.